a world over 100 years ago, where the secrets of the oceans were guarded by smoke and science. In the 1920s, naval warships vanished behind brilliant white clouds, created not by magic, but by an extraordinary chemical reaction. Today, we uncover the story of titanium tetrachloride and naval ingenuity. Before we dive into this remarkable history, take a moment to subscribe and hit the notification bell. If you love uncovering forgotten science and astonishing pre-WWII footage, this is your front row seat. Like, share, and comment your thoughts. Let's explore these hidden moments of innovation together. The early 20th century was a period of extraordinary technological exploration. Before World War II reshaped the globe, nations experimented with ways to protect their naval fleets, test strategic innovations, and assert maritime dominance. Among these lesser-known techniques was the use of chemical smoke screens, specifically liquid titanium tetrachloride, to hide warships from prying eyes. Footage captured from these experiments, now over 100 years old, gives us a rare window into the daring ingenuity of naval engineers and chemists. Watching these clips, one might notice a plane releasing a silvery white cloud that spreads across the ocean's surface. Yet what looks like a cinematic flourish is a calculated scientific strategy designed to mask vessels from observation. Titanium tetrachloride is a chemical compound that, when exposed to humid air, undergoes a dramatic reaction. On contact with moisture, it rapidly hydrolyzes, forming dense clouds of titanium dioxide, a white, opaque compound, and hydrogen chloride gas. Let's break it down in simpler terms. Imagine a clear liquid that, the moment it meets the moist air above the ocean, instantly transforms into a thick, blinding fog. This reaction is almost instantaneous, creating a smokescreen capable of obscuring a ship from both visual observation and early aerial reconnaissance. The brilliance of titanium tetrachloride lay in its simplicity and reliability. Unlike other smoke-producing methods, which relied on combustion or heavy fuels, titanium tetrachloride worked at room temperature and required minimal infrastructure. In a world where navies were constantly evolving, this was revolutionary. The 1920s were a transformative decade for naval aviation. Airplanes were no longer limited to reconnaissance missions. They became tools of deception and strategic advantage. In the footage, a small biplane approaches a naval warship. Its mission is precise: release a measured quantity of titanium tetrachloride at a calculated height above the vessel. As the chemical meets the ocean air, white clouds billow around the ship, concealing it from enemy observation. The process was both art and science, a carefully choreographed dance between pilot and chemist. Pilots needed exceptional skill. Dropping the liquid too high or too low could reduce the effectiveness of the smoke, while improper distribution could leave the ship partially exposed. The footage shows the meticulous care with which these maneuvers were executed, offering a rare glimpse of early aerial naval tactics. Between World War I and World War II, global powers were acutely aware of the vulnerability of their fleets. The ocean was no longer a passive theater of defense. It was a stage for innovation. Naval engineers sought to protect warships, not just from enemy fire, but also from espionage. Caméra, reconnaissance plane, and even early sonar technology posed a constant threat. The ability to obscure a vessel in plain sight became a critical strategic advantage. The use of titanium tetrachloride was part of this broader movement. While other nations experimented with camouflage nets, smoke grenades, and optical illusions, the chemical fog offered a near-immediate solution. This footage, captured during experimental exercises, demonstrates the lengths to which naval forces went to maintain secrecy. Deploying titanium tetrachloride was not as simple as pouring liquid overboard. It required specialized containers, careful handling, and an understanding of chemical properties. Planes were fitted with tanks designed to release the liquid in controlled bursts. As the aircraft flew above the ship, valves opened, and titanium tetrachloride was released in a fine mist. The moisture in the ocean air triggered the hydrolysis reaction, instantly forming a dense white cloud. Footage from these exercises shows the smoke spreading like a living thing, engulfing the ship in moments. Sailors on deck moved carefully through the mist, aware of the chemical's reactive nature. Though titanium tetrachloride produces only a small amount of hydrogen chloride, gas corrosive and irritating, it was deemed safe for short-term exposure during training. Why titanium tetrachloride? Chemists and engineers of the 1920s recognized its unique properties. Unlike smoke from burning oil or coal, which could linger unpredictably or leave residue, titanium tetrachloride's reaction was immediate and controllable. Titanium dioxide, the product of this reaction, is now widely used in paints, sunscreens, and industrial coatings. In the 1920s, its potential as a smoke-generating compound was still being explored. Naval strategists quickly realized its value. The footage captures this perfectly. Thick, billowing clouds form almost magically from a clear liquid, transforming the landscape of the open sea. Watching these clips today, it's easy to underestimate the precision required to achieve such effects. Yet each puff of smoke represents meticulous planning and experimentation. There is an undeniable visual allure to these early experiments. The black and white film emphasizes contrast, making the white titanium dioxide clouds almost ethereal against the dark water. The slow, deliberate movements of the plane create a sense of tension and purpose. Sailors and pilots of the era were acutely aware of the stakes. Every drop of liquid released was a test of technology, chemistry, and human skill. Footage shows the transformation. A once visible warship fades into a cloud, leaving only a ghostly silhouette behind. This visual spectacle is more than entertainment. It is a historical record, documenting the fusion of science and strategy in a world on the brink of global conflict. Handling titanium tetrachloride required caution. Exposure to the skin or eyes could cause burns, and inhalation of the fumes was hazardous. In the footage, sailors wear protective clothing, while pilots handle the chemical with care, highlighting an early understanding of occupational safety in chemical operations. Additionally, environmental conditions played a critical role. Wind direction, humidity, and temperature affected the dispersion of the smoke. Pilots and engineers needed precise calculations to ensure the fog remained dense enough to conceal the ship without dissipating too quickly. This was early applied chemistry at its most practical, a combination of observation, experimentation, and iterative problem-solving. Smokescreens were not merely theatrical, they were strategic. In times of tension, concealing a fleet could prevent reconnaissance, delay enemy targeting, and protect critical assets. Titanium tetrachloride provided a unique advantage. Unlike camouflaged ships, which could still be identified from the air or by binoculars, chemical fog created an instant barrier, masking the ship completely. In the 1920s, when aviation technology was still in its infancy, such innovations gave navies a critical edge. Footage of these exercises reflects that strategy in action. Observers might notice how carefully the cloud spreads, how the ship seems to vanish, and how the plane maneuvers with precision, each element a testament to careful planning and scientific insight. Beyond the spectacle, this footage teaches us about human ingenuity and adaptability. In an era without digital cameras, radar, or satellite imagery, navies relied on chemistry, physics, and skillful coordination. It is also a reminder of how science and warfare have long been intertwined. The pursuit of security and advantage drove technological breakthroughs, many of which later found applications in peaceful industries. Titanium dioxide, once a tool for concealment, now brightens paints and protects our skin from the sun's rays. Watching these clips today, we see more than smoke. They represent curiosity, experimentation, and the timeless human desire to innovate in the face of uncertainty. Modern audiences may find the footage captivating not only for its historical content but